Here, this is where the concept is this kind of thing. Let's say I had 5 and x plus, and if I had that 5x plus 1, I would multiply the 5 times the x, make it 5 times x, and then multiply it to the 1 to make it 5. So the intermediary thing that is often shown is to have it 5 times x plus 5 times 1, which I think is a complete waste of time to write it out like that. But you do write it out that way, and that would be the correct answer. But you have to remember to multiply this to both of the things inside. Well, in this case here, we have this 4x is going to multiply to the x plus 5. So it's 4x times the x plus 5, and then it's the minus 3 times the x plus 5. That's the concept that that you're going to do here, where you're then going to do 4x times x is 4 times x squared, because there's a 1 in front. So 4 times 1 is 4, and x times x is x squared. And then we're going to multiply it to that. So 4 times 5 is 20, and there's x times no x at all, so it's just like x times 1. And then we're going to do it to this one, negative 3 times x, and negative 3 times 5. And then you put together these like terms. So we get 4x squared plus 17x minus 15. That's one method of doing it, where you take one of these and you up and do it as two possible ones. So the 4x times the second one, and then the negative 3 times the second one. So the second one, whoops. Okay. There's the second one, and there's the 4x times that one, and the negative 3 times that one. I like colors. Now, to let you know, you could decide to do this one with the two parts, or so it would be x times 4x minus 3 plus 5 4x minus 3. You could multiply that out and you would get the same exact answer. You would get this here. Now, there's another way to do it that's sort of the same thing, same exact concept, but it just, if you realize this and recognize what to do, this becomes a little easier. Take the 4x and draw a little line over here and do 4x times x is 4x squared. Then take the 4x times the 5, and that's plus 20x. Then negative 3 times x and negative 3 times 5. And then you combine the two like terms, and it's basically one less step. It's the same exact concept, but when you're doing a bunch of these and you're doing them over the next 4 or 5 years in every math class you do, after a while it becomes a lot quicker just to do a shortcut kind of thing like that. Get the same exact answer. All you have to do is keep your wits about you to recognize that you're doing this one times that and that, and this one times that and that. And then I'll do the green ones for that one. And you get the same exact answer. Okay, let's do it for these couple here. Well, these are practice ones. I'm going to play with one of them, maybe leave one for you. Okay. Oh, yep, thank you. This should be an X there. I forgot to put the X. So watch out for that. It's obviously easy to do to sometimes forget an X. And I did. All right, so here, if you do 5x times 3x, that's the 15x squared. 5x times 2 is plus 10, and the x, minus 1 times 3x, minus 3x, and minus 1 times 2. So let me check those. 5 times 3, x times x is x squared. And then 5x times 2 is 10x, because you only multiply the things you can. Just do whatever you're allowed to. Negative 1 times 3x just makes it negative, and it makes the other one negative. And then these two can be put together. Okay, plus 7x, so 10 take away 3. Now, I'm going to make a little point about something here, is that one of the things that happens is Oops. Little things can sometimes be forgotten just because you're focused on something so much that you don't realize you forgot to write something. Evidence of that is what happened here when I forgot just a moment ago to put that X in. And if I left it that way and not thought about it, I would have maybe thought, oh, 17 take away 15 would be 2, and then I'd give the wrong answer. In fact, it would have been wrong without the X2. The other thing that sometimes people tend to forget is when they do the X times the X, they just forget to put the square. They just forget that X times X is X squared, or they just forget to write the 2 as a square. And then sometimes they add these two together because they think, oh, yeah, they both have X's, they're like terms. Well, they're really not, because there's an X squared there. And so basically watch for that. And most of the time, you're going to have these as separate and a squared and a non-squared. So if there's one of them missing, you have to think, uh-oh, what's going on? Let's go back and double check everything. Okay. I'm going to leave this one over here as a practice one. So do that one if you wish to yourself. And when I post this, you'll have this, you'll be able to see this one completed. And the same with these others. In fact, all of these are pretty much the same thing. The method is all exactly the same, just multiply and multiply them out. Okay. So now, having seen that and seen the two ways of doing it, where you can separate them, multiply them, or you can multiply them like that. You know what? I think I'll do one more of these. Let's come down to this one because it's such an important topic. I'm going to do 3x times that. That's 3x squared minus 15x plus 5x. And that's positive and negative, and 5 times 5 is 25. So it looks like I have only one of them that's an x squared. The two that are x's I'll put together. So negative 15 plus 5 is negative 10x minus 25. And when you know your multiplication numbers well, this becomes a pretty fast thing that you can do. But don't do it fast just to be fast. Make sure you're accurate. Accuracy is your number one priority. And then you want to go fast enough so you're not spending all day on doing these things. Okay, let's look at the second page of this thing, where it's multiplying binomials and trinomials. We're going to do the same exact concept. And I'm going to do it where I'm going to have the 2x times the 3x squared, the 4x, and the negative 5. And then I'm going to do the negative 1 times each of those others. So I can either do it where I'm going like this, or I can do it where I have 2x times 3x squared plus 4x minus 5 minus 1. I think I put that minus 1 in the right place there. And then the same 3x squared plus 4x minus 5. This is supposed to be a 3. That one's a 5. If I do it with lines like that, all I think is it's 2x times each one of these. So 2x times 3x squared is 6x squared. 2x times 4x is plus, wait a minute now. And I've just noticed, wait, hey, look, I'm going to get 8x squared here. And that tells me, wait a minute, what's up with that? Why are they both squared? And that's because I wasn't thinking at first about the fact that this x is multiplying to this x squared. And so when you have one of them and two of them and you multiply them, you get 3 of them. So I need to make that 2 into a 3. Yeah, let's make it a neat one like that. And so I just did that one. I did this one. Now I'm going to get this one, which is negative 10x. And then the next one I'm going to do, I'll use the red one for that, is negative 1 times that. And I'm going to put that underneath it. Negative 1 times 3 is negative 3x squared. And actually for that, I'll go back to blue. And then the next one is negative 1 times 4x is negative 4x. And negative 1 times negative 5 is positive 5. So I get a 6x cubed plus 5x squared. This method of putting them on two lines here and underneath each other, the underneath like terms, makes it a little bit easier to combine the like terms afterwards. And then that looks like it's going to be negative 14x, and that's going to be plus 5. Now, let's see if I get the same answer doing the other way. All right. I'll use black one for this now. I do this times this, and I get 6x cubed that one. And this one, which is plus 8x. And this one, which is minus 10x. And here I'm going to get negative 3x squared, negative 4x. Oh, let's get these lines all in here. And a positive 5. So I look at this and I see only one is cubed, so that will come first. And I have an x squared. There's only one. Oh, wait a second. When I multiply this, the first thing I notice is that, look, I've done this now a couple of times. Oh, I want those to go away. Move them back there. Where this thing's not cooperating. Give me a moment when you get it to work right. Get back there. It wants to hide things from me when I try to highlight them. Okay, I'm going to go like this. That 2x times the 4x. I got the 8, but I forgot when I did the 2 x's that that's supposed to be a square. Okay, there, that read more minus. So notice it's really easy to lose an exponent. It's really easy to not write it down. Even if you're thinking it, you sometimes don't write it. So be really careful with that. That's probably one of the biggest things, an unintended kind of error, where someone knows better but just isn't thinking about it. And I've just done it 3 times, once on purpose, but twice not on purpose. Okay, now over here, let's say I've got 2 of these that are squares, and 8 take away 3 is plus 5x squared. And then I've got these that are negative, that are x's, so that's negative 14x, and only one of them that is without an x. And it's the same answer. So you can do this kind of thing either way, as long as you're very careful with your exponents and the x's and the numbers and all of that, and just be accurate. All right, now, there's another one underneath it. I don't necessarily want to do it. Actually, there's 2 of them. So I'll do one of these, and you can do one of these yourself for practice. But let's take a look at something else here. I'm going to rewrite this one for a second. Well, not for a second. I'm going to rewrite it over here, and it'll stay there. So I just switch those around. Well, I can do that all day if I want to, because the concept there, you can switch them around if it's multiplying. This is like 2 times 3 is equal to 6. I think everybody agrees with that. Well, if I switch them around, 3 times 2 also equals 6. So when you're multiplying things, like if I put parentheses, that's another way of showing multiplying, you can just flip them around as long as they stay inside the parentheses, they stay in the right order. So what this means is I can do the 5x times 2x squared times the negative 7x times the negative 1, this times that times that, that times that. Over here, I could also do that same thing. I could do this times this, and then I could do this one times this one, then I could do this one times this one. Or I can use the back one just as if it was in the front, and I could do 5x times 2x squared, 5x times negative 7x, 5x times negative 1, and then negative 3 times 2x squared, negative 3 times negative 7x, negative 3 times negative 1. Gets a little tedious. And then it would be the same as if it was this one. And it doesn't matter, because it's multiplying. You're going to get the same answer no matter which order, as long as you keep them in the right order inside their parentheses. All right, so after all of that, I'm going to stick to the basic one here, and I'm going to do 5 times 2 is 10x squared. Oops, it's not squared. I caught this one immediately here. This time that it's cubed. X times x squared. And then 5 times negative 7 is negative 35, and x times x is x squared. 5x times negative 1 is negative 5x. And then negative 3 times 2x squared. Well, it's an x squared, so it's going to go under here, because I like to do this where I put underneath it to keep the like terms. That's positive 21x. And then this one is negative times negative is a positive, and it's positive 3. So that gives me 10x cubed minus 41x squared plus, well, 21 take away 5 is a 16x plus 3. Okay. And remember on these that the x's don't, when you're subtracting and adding with variables, you're only actually adding or subtracting the coefficients. So sometimes people are just busy and don't think about it, and they don't realize, okay, if I have negative 35 minus 6 is negative 41, that's not x squared take away x squared. It's 35 of them, negative 35 of them, and minus another 6 of them to give you minus 41 of those things. All right. So be careful of that, because sometimes people just aren't really thinking straight because there's just many things going on, and they just delete the exponent saying, oh, well, they subtract each other. No, it's only the coefficients that subtract each other. Okay, this one will be a practice one that you can do on your own. You can take a picture of it, pull it up from the what I have it posted on the web in Google Classroom, so you can pull up the blank one and do it. And what's the other thing? I'll show you, put up the answers when I post it over the weekend. Now, there's an application type of problems, and there's 2 of these that I have. Okay, and I'm going to do one of these here, and you'll see how to do it and try to do it yourself. I like this kind of a problem. That's a little bit of a hint. I like this kind of problem. So we're talking an area. Remember, area of a rectangle is length. Area equals length times width. So the really big area, the area equals the length, which is 9x plus 4, times the width, which is 5x minus 2. And then the small area, I'm going to use blue for that one. The small one there, and that's not quite a good rendition, but okay, good enough. The area of that one is going to be the length, x minus 4, times the width, 2x plus 3. And you could call this one the width, the length if you wanted to, and this one the width. It doesn't matter which one comes first, because again, when you're multiplying 2 things, they can be flipped, but as long as they're inside the same order inside the parentheses, you're going to have the correct answer. Okay, and mainly because of negatives, you have to be careful. So what we're really doing is we're doing the area of this one, subtract the area of that one. So we're doing this, subtract that. So one way to look at it is I'm doing 9. I'm going to come way over here. I'm going to do 9x plus 4 times 5x minus 2, subtract x minus 4 times 2x plus 3. Because this is the big area minus the smaller one. Okay, so that's really what I'm doing, is I'm just subtracting them after I'm multiplying them. It's order of operations. So let's actually go through this and do it. So 9x times, I don't want that parentheses to go away. Get back here. There. Okay, so I'm going to do 9 times 5 is 45x. And it's x times x, so it's x squared. I was careful about this, thoughtful about it this time. And then the 9 times negative 2 is negative 18. And it's just x times like a 1 here, so there's just x. Okay, double check that. 9 times 5, 9 times negative 2, looks good. And then I'm going to do this one, which is going to be plus 4 times 5 plus 20x. And then this one, which is minus 8. Okay. So next I'm going to do over here. Now, here's the thing. I'm going to subtract all this. I think part of what I should do is first work this out. Where I'm going to do 45x squared, that's plus 2x, because it's negative 18 plus 20, okay, minus 8. Now, I'm going to do this part before I subtract. Okay, so I'm going to do x times x is 2x squared plus 3x minus 8x minus 12. Let me check my numbers again. I got the square. That's a 2. That's a 3x. Here I have 4 times 2 and negative. 4 times 3 and negative. Okay, that works. So this one's 2x squared minus 5x minus 12. So if I'm going to subtract them, I'm going to bring this one over here, and I'm going to do subtract 2x squared minus 5x minus 12. So 12 there. So you have to be really thoughtful about that, because remember the lesson last month where if you have one of these and subtracting the other one, you have to do minus each one thing. Minus that, minus a negative makes it plus, minus a negative makes it plus. So let's go down. That was 45, take away 2 is 43x squared. This negative and negative makes that plus 5. So 2 and 5 is plus 7x. And this negative here, we're subtracting, and that negative is plus 2. So these became pluses. So it's negative 8 plus 12, or 12 take away 8 is plus 4. That represents, oh, come on. It's not cooperating for me to write, so I'm doing what I can. Represents the area, and I think this was a pool problem. No, oh, the area of the shaded region. Of the shaded region. Because it's combining them together, it's subtracting it, so it represents that area. So think about what it means then that you're subtracting them. You have to figure out what each of them are simplified, and then subtract the one from the other, based upon the problem there. Okay, you take notes if you are on this, and think about it. And then this one here is the same idea. So if you wish to do it, take a picture or a screenshot, or write about it, write it down, and then do that on your own. And I'll post this with the correct answer on over the weekend or sooner.